Thanks for joining us. 1.9, perimeter, circumference, and area. We're going to start with our concave polygon, and it's going to look like our regular polygon. Let's pretend like we're going to draw a rectangle or a box, but we're going to change something, and this is what it's going to look like. So when we change this figure to a concave polygon, again, it's going to look like our normal box or normal rectangle, and then what happens is there's a certain part of it that gets caved in. And so when that happens, this is known, or this is called, a concave polygon. And how we can remember it is that when you have a concave polygon, it will be caved in. So that's kind of the term that we want to think of. We could draw a shape that does this, and then ends up looking something like that. So getting back to our definition, it says a polygon in which one or more diagonals is located outside the figure. And a diagonal goes from one vertex to the other one, so it could look something like that, or if we went from here up to there, and from here up to there. And so you can see that these diagonals are located outside of the shape due to the caved in effect that we have with the concave polygon. With a convex polygon, this will just be our rectangle, and it could be our triangle, our square. So it's just our normal regular shaped polygon that we're used to seeing. We could draw a pentagon, we could draw a hexagon. Okay, and what happens is when we draw these diagonals, all of these diagonals be inside of our figure. And so that would be an example of a convex polygon. Next, we have the term polygon. It's a closed figure made of line segments. We should already know that. On perimeter, it's going to be known as the distance. Whoops, we should cross this out. It's not circle. It's going to be the distance around a polygon. Excuse me. And then circumference is the distance around a circle. So let's go and look at our shapes here. We have a rectangle, and I'm going to put a mark here and a mark here. The reason why I did that is that these two lengths, or these two segments, will always be the same measure in a rectangle. And just like these opposite sides here, then I'll put two marks to show that these two sides will each be the same measurement. So this is known as our length, this is known as our width, and this will also be a length, and this will also be a width. So if we wanted to find perimeter, we just add up all of our sides. And if we were to do that, we would add up 2 L's and we would add up 2 widths. For area, it's just going to be length multiplied by the width. Okay, I've also seen it as base times height. Okay, and length and width are interchangeable. Same with base and height. You can interchange these. On a square, all sides are the same. And so let's assume that we named one of these sides S. Well, to find perimeter, we would add up 4 S's. So we're going to say perimeter is equal to 4S. And the area is going to be the same formula that we have for length times width or base times height, but it's just going to be S times S, which would be S squared. For a circle, let's start with our center point and then draw a segment to the end point of the circle. And what I have just done, since this goes from the center point of the circle to an end point on the circle, this is my radius. And there are many more radii that I can draw. I can draw them all over the place. Okay? And if I were to extend this radius all the way through, or went to the other side, that would form a diameter. So, in a sense, we can think of one diameter is equal to 2 radii, so d is equal to 2 times r. Now for our circumference formula, it's going to be the distance around this circle all the way around until we get back to the beginning, and that's going to be known as 2 pi r. It can also be expressed as pi times d, and that should make sense because remember that it takes 2 r's to make 1 d. So it's the same formula, except we're going to express 2r as 1 diameter. The area is going to be pi r squared. Let's go down to the problem. First problem, if we want to find perimeter, we can add up all the sides. Since this length is 25, this has to be 25, this width is 18, this width is 18. We add up all the sides. 50 plus 36, perimeter is going to equal 86 feet. To find the area, we just take 18 times 25, and that's going to be 400. And remember that area is going to be squared, so it's 400 feet squared. Why is it squared? Well, feet times feet is feet squared, just like x times x is x squared. With the circle, it's always important to define the radius. We're given a diameter, so the radius is going to be 1.3 and 1.3 because that adds up to 2.6. I'm going to put up here radius equal to 1.3. And you can also label that d is equal to 2.6 if you really want to. C is equal to 2 pi times 1.3. Multiply that out, we get 2 times 1.3 is going to be 2.6 pi. Okay, and this is known as an exact answer. Now, if you want to, or if on a test they ask for an approximate answer, that means you'd have to enter in 3.14 for pi. And so you would just take this number 2.6 times 3.14, and whatever that equals would be your solution. Alright, the area, we're going to take area is equal to pi and then radius squared, and 1.3 squared is 1.69, and then pi centimeters squared. Now remember that this answer is known as an exact answer because it's in terms of pi. If on a test they ask for an approximate answer, then we would have to enter in 1.69 times 3.14, and then that will give us our approximate answer. Sometimes we're asked to find shapes that are more than just one shape. So note we have one shape right here. It looks to be like a square, but we're not sure yet. And since we know this is 5 and 5, then I can put a 5 here and a 5 here. So this shape is in fact a small square. Doing a little further research, if this is 5 and this whole length is 14, we know this length will be 9. And since this is 9 and this is 9, we know this is 9. And then since this is 9 and this is 5, we know that this is going to be 4. So as of right now, we have enough information to solve for perimeter. Let's just add up all of our sides. 9 plus 4 plus 5 plus 5 plus 5 plus 9 plus 9. So that gives us 13, 18, 23, 28, 37, 46 feet would be our perimeter. Now we didn't use a formula. We just kind of went around and added up all the sides. Sometimes that's easier than worrying about formulas. The area, we're going to find the area of this square, and then we're going to add that with the area of this square. Okay, so we have two squares. So let's find the area of each one, and then we can figure out the total area. So the area of my big square is going to be 9 times 9, so we have 81. The area of the small square is going to be 5 times 5, which is 25, so I get 106 feet squared. That's the area for these two shapes. Next, on problem 4, anytime you see a mark and these marks, that means all of these lengths are the same. Since we have an 8, we can fill in the rest with 8. Also, please notice we have a 30 here and then 2 marks. So these 2 marks will also be the same. So let's put 30 down for this length. Alright, first, let's find perimeter and we'll worry about area. Remember that for perimeter, we can just add up all the sides. So 30 plus 8 plus 8 plus 8 plus 30, and then plus 8 plus 8 plus 8. So we're at 24, 48 plus 60 is 108. So we have 108 units. To find the area, let's extend this shape with this line, and let's create two shapes just like we did on this problem. So now we want to find the area of this piece and find the area of this shape. And they're both 8 by 30 rectangles. So we're going to do area is equal to length times width, which is going to be 30 times 8, which gives me 240. Same thing down here, 30 times 8, 240. We add up the area, we get 240 plus 240 is 480. We'll call this units squared. On to problem 5. We're asked to find the area of this shaded region. Now, what appears to have happened here is we have a square that's been inscribed inside our circle. Let's first start off with what we know. We know that the square has a side length of 8. So I'm going to label all my side lengths as 8, 8, 8, and 8. And then we know that the radius is going to be 11.3. So remember that from the center point, when we draw out a segment to an endpoint on a circle, that will form our radius. So this length is going to be 11.3. All right, at this point, I'm going to make a note that this figure appears to be not drawn to scale. And the reason why I say that is, if you look at the side length of 8, this appears to be longer than this segment here. And yet this segment is going to be 11.3 because it's given to us. Okay, but clearly it's not drawn to scale because this looks less than 8. The other thing that we should do is look and decide what is the problem asking us to do. And it's asking for us to find the area of the shaded region. So that's everything in here, everything in here, and everything in here. Hopefully you can see that if we find the area of our circle, and so the area of our circle is going to be much greater than the area of our square because it's a bigger shape. So if we find the area of our circle minus the area of our square, that will give us the area of our shaded region. For the circle, we're going to start off with area is equal to pi and then 11.3 squared. Now, in the problem, it does not say what kind of answer that they want. Let's first assume they're looking for an exact answer. If they want exact, we have to leave the answer in terms of pi. So 11.3 squared is going to be 177.69, and then we have to leave the pi in there, and then minus, well, the area of the square is easy. It's going to be 8 times 8, which is 64. So the area of that shaded region, as far as an exact answer, would be 177.69 pi minus 64. We can't subtract 177.69 and 64 because we have a pi, and we don't have that here. Therefore, these aren't like terms. Now, sometimes on tests, they might ask you to solve and give in what's known as an approximate answer. And when that happens, they want you to use 3.14 for pi. So we're going to take our 177.69 and multiply that by 3.14. When we do that, we get 400.95 and then minus the area of our square, which was 64, which would give us a grand total of 336.95 centimeters squared. And so our approximate answer probably makes more sense to us because we know that it's 336.95, almost 337. The algebra review I will let you handle. Thanks for joining. See you next time.